All right, so this is part two of the light calculations that are in your notes packet. So now we're going to look at a different one. And this particular formula, it uses Planck's constant, okay, to calculate energy and a relationship here with frequency. So we're going to say that the relationship between frequency and energy, we know that frequency and energy have a direct relationship. We learned that already. All right, so they're going to be direct because the higher the frequency, the higher the energy, or the lower the frequency, the lower the energy. Okay, so that's why we have a direct relationship with those two. And so here we're just going to familiarize ourselves with our variables, right? This big E is just energy. In energy, we have the unit joules, all right? Another like SI unit derived unit, if you will. And then we have H, all right? The H is for Planck's constant. Planck's constant, constant. And the number is always going to be the same. So when you see that like plain H in your formula, you're going to do 6.63 times 10 to the negative 34, itty bitty, joules per second. Okay, joules per second. And then we have our frequency. All right, so frequency, we already know about frequency. So frequency is in hertz. Okay, so Planck's constant, it's just a really, really, really small number that helps us quantify kind of like the energy cost per packet of light, okay, per photon. So it's a tiny little number. It's kind of like the price tag of a photon, I think might be a good way to think of it. But it's a number that scientists can use pretty much all the time if they need to help them solve these things. So that is the case. So it says, if we're going to apply this, it says, what is the energy of a photon of light if the frequency is 5.44 times 10 to the 15th hertz? All right, so we know that if you were to get that problem, you're not going to use this formula up here. Okay, because this one doesn't have energy in it. You need a formula where energy is involved. Okay, so let's put energy here as a variable. And then we have our Planck's constant, and then we have our frequency. All right, so we said our frequency in this particular problem, it is 5.44 times 10 to the 12, no, 15 hertz. And then Planck's constant is 6.63 times 10 to the negative 34 joules per second. Or it's actually joules times seconds. It's not per seconds. If it was per seconds, it would be joules divided by seconds, but it is joules per second. I'm sorry. It is joules seconds, which is kind of weird to say it like that, but that's what it is. And then we have our energy, which is our X. Okay, so according to this, energy equals Planck's constant times frequency. And so if I'm going to solve for energy, my equation is already in the proper format. All right, so I don't need to rearrange it at all. So I'm simply just multiplying 6.63 times 10 to the negative 34 joules per second. Okay, times 5.44 times 10 to the 15 hertz. Okay, but remember that hertz is like 1 over a second. All right. And if that's the case, then we actually cancel out when we do this calculation, these seconds are going to cancel out. and we're going to be left with the joules that we need. Okay, and so it's 6.63 second EE negative 34 times 5.44 second EE 15, enter. And we get 3, let's just round to 3.61 times 10 to the negative 18 joules. All right, and so that is our answer. Okay, all right, we'll do a little bit of another practice problem with that. Okay, it says if a photon has energy of 2.93 times 10 to the negative 25th joules, what is the frequency? And it's asking us what type of electromagnetic radiation is this photon? Okay, so if we know that E is going to equal H times frequency, the energy now they're giving to us, okay, which is different than the last problem. So 2.93 times 10 to the negative 25 joules. And then our Planck's constant is always going to be 6.63 times 10 to the negative 34 joules seconds. And then our frequency is our unknown. And so if this is my equation, how I start it, and I want to solve for frequency, I need to get it by itself. And so I'm going to divide by Planck's constant on both sides. And isn't that easier than writing all of it out? You know, like um, if we don't rearrange our formula first, we end up writing down more numbers and more things. And the more you write down, the more opportunity for error. So, so it's just a little easier to do it this way. And so now we have frequency equals energy over Planck's constant. Okay, and so energy is 2.93. Let's make that a little bit better, easier to read. 2.93 times 10 negative 20 joules seconds over 6.63 times 10 to the negative 34. Oh my goodness. It's just joules up there, and this one's joules seconds. Okay, I have taken cold medicine. I am feeling a little under the weather this weekend. And so I took some Dayquil, and man, I do have a little bit of a loopy head, but I am in it with you guys. This is correct. All right, and our joules then cancels out. Okay. And remember how our unit for hertz is 1/2? Like that's basically, it means the same thing as hertz. Well, now you can see kind of how this formula works and how we're left with the right unit. And that kind of means, hey, we might be on track with the way we set this thing up. Okay, so 2.93 second EE to the negative 25th. And then we're going to divide by 6.63 second EE um, to the negative 30. It kind of looks like a 39. It's a 34. Okay, enter. And so this is a weird value that I'm getting. Let's put it in again. I don't know why it's giving me a weird value. I must have hit something wrong. Okay, so 3.0 second, no, 2.93 second EE to negative 25 divided by 6.63 second EE minus 34, enter. Okay, so this is the nice thing about your calculator is that it's going to give you this answer in scientific notation, and I'm not quite sure why it didn't here. It would have been nice. And scientific notation, all right, this answer is going to be like 4.42 times 10 to the 8 All right, I'm just looking here. So like, I'm doing the scientific notation myself. Okay, so I'm like moving over my decimal place 1, 2, 3, 4, 5, 6, 7, 8 times, and that's how I know that I have 10 to the eighth. But on your calculator, it should have done it for you. And I'm not quite sure why it didn't here. So I think it usually does. I must have hit something to take it out of the mode I was in or something like that. Okay, so that is it. All right, that concludes this part two, which is going over the energy formula and as it relates to Planck's constant and frequency. And then the next one in part three, we're going to combine these two formulas and solve these problems using a combined formula. All right, thanks.